Sound is a form of energy that spreads out through space. When a singer sings, the vocal cords of the singer's throat vibrate, causing air molecules to vibrate. A series of ripples in the form of a longitudinal wave travels through the air. Vibrations in the eardrum send electrical impulses to your brain, and you hear the singer's voice. The source of all sound waves is vibration. In a piano or guitar, a sound wave is produced by vibrating strings. In a saxophone, a reed vibrates. In a flute, a column of air at the mouthpiece vibrates. In each case, the original vibration stimulates the vibrations of something larger or more massive. The sounding board of a stringed instrument. The air column within a wind or brass instrument. The air in the throat and mouth of a singer. This vibrating material then sends a disturbance through a surrounding medium, air, in the form of longitudinal waves. The frequency of the sound waves produced equals the frequency of the vibrating source. We describe our subjective impression about the frequency of sound by the word pitch. A high-pitched sound, like a piccolo, has a high vibration frequency. A low-pitched sound, like a tuba, has a low vibration frequency. A young person can normally hear pitches with frequencies from about 20 to 20,000 hertz. Let's test your hearing. Make sure you don't have your volume up too loud. As we grow older, our hearing range shrinks, especially at the high frequency end. Sound waves with frequencies below 20 Hz are called infrasonic. Sound waves with frequencies above 20,000 Hz are called ultrasonic. Humans cannot hear infrasonic or ultrasonic sound waves. Dogs, however, can hear frequencies of 40,000 Hz or more. Bats can hear sounds at over 100,000 Hz. When you clap your hands, you produce a sound pulse that goes out in all directions. Each particle moves back and forth along the direction of motion of the expanding wave, like a ripple in a pond. A compression travels along a spring similar to the way a sound wave travels in air. Opening and closing a door produces compressions and rarefactions. When the door is opened, a compression travels across the room. When the door is closed, a rarefaction travels across the room. A compression is a pulse of compressed air. The molecules in a compression are packed together and the pressure is relatively high. A rarefaction is a pulse of low pressure air. The molecules in a rarefaction are spread apart. On a smaller scale and more rapid scale, this is what happens when a tuning fork or a speaker vibrates. The vibrations produced by the tuning fork or speaker are much higher in frequency and lower in amplitude than the swinging door. You can't see the effect of sound waves on the curtain, but you hear them when they meet your sensitive eardrums.